What's up, y'all? We are continuing our subnetting video series. If you are just jumping in this video series, you really should go back and watch all of them because you're probably not going to have any idea what we're talking about. So, we're going to dive into practice problems for subnetting. So, how many usable hosts does a CIDR of /26 have? Well, let's see. We've been working with /26 this whole time, so it's 64, right? Wait, what? Oh, it's asking for usable. What is usable? Usable is always 2 less than total. So how many hosts? 62. Take a look at the next question. How many valid hosts does the network have with a subnet mask of 255.255.255.248? Wait, valid, we have not used that term. Correct. We are introducing a new term right now. Usable and valid are the same thing. Usable and valid are the same thing. Tracking? Hopefully. So let's crunch this. So what's it going to be? It's going to be 2 less than total. So how do you do this problem? How do you do this problem? Well, you have to figure out how many bits you have left to assign to hosts, and that'll give you total hosts. You can also look at the cheat sheet. What if you look at the cheat sheet? How easy is this problem to answer? Well, just look at your cheat sheet and answer it right away. But let's crunch the numbers here. Let's do it in binary. So, and you might be able to do this in your head at this point. Convert that subnet mask to binary, right? So it's going to be 8 plus 8 plus 8 plus, what's 248 in binary? Well, it's 1111 1000, I think. I just did that in my head. I hope I'm right. Hopefully I'm right. So, how many bits do you have left to hand out to hosts? Well, you have 3. The 3 zeros at the end. Those are the only 3 bits you have left to assign to hosts. So how many numbers does that get you? Well, if you write it all out on a piece of paper, you have, what's the largest number that you can make with 3 bits of binary? It's 111. And what's that in decimal? It's 7. So you have the numbers 0 through 7 that you can use to hand out to devices. So you have 8 total numbers, or 8 total hosts. But we're not asking for total. We're asking for valid or usable. And usable is always 2 less than total. So you have 6 total hosts that you can hand out to devices on this subnet. Pretty straightforward if you just crunch the binary. Now, let's move on to the second practice problem. What is the network portion of the public IP address 208.121.20.54? Ooh, this is a good question. Very simple question, but you have to do lots of things, okay? You need to memorize that table, the class A, B, and C IP table, right? So what's the first thing you need to do? Well, you need to figure out what's the class of this IP. You were told it's public. What's the class of this IP, right? Is it class A, class B, or class C? And then you have a default subnet mask for each of those classes. And look at the default subnet mask, and it will tell you what the network portion of that public IP address is. So hit pause, look it up, and come back with your answer. Well, what'd you get? 208.121.20, the first 3 octets. That's the network portion of that public IP address. Let's move on to the next one. Here we go. This kind of problem right here is like my favorite kind of subnetting problem because you have to find all of the numbers. So you're given the host IP address, you're given a subnet mask, you have to find network ID, broadcast, number usable, and first and last. So how do you attack this problem? How do you attack this problem? Well, you need to sketch out subnetting tables, which if you have been doing your subnetting assignments, you already know how to do. So take a look at it. Network ID, What's the first thing you need to find out? You need to find out where that IP address is. What subnet is that IP address sitting in? You can't just give a random network ID for a random subnet. You have to give the network ID for the subnet where that IP is sitting. So you have to figure out what subnet that IP is in. So you need to sketch out your ranges for all your subnets and figure it out. And that will tell you the network ID, the broadcast IP, first and last, and number of usables easy to figure out. Look it up. Let's find that out with the cheat sheet. So you're given this, you're given 224.224. So let's look at the cheat sheet. Let me go back to the cheat sheet here and find that. Here we go. So 224, and that is the subnet mask. So start with subnet mask. You're given 224. So take a look at it. So range size 32. Okay, now we probably should talk more about terms here. Range size is the same thing as increment. I've also heard magic number. It is also total hosts. They all mean the same thing. Total number of IP addresses on that network, 32, right? All right, so let's go back to our practice problem here. All the way back. There we are. So number of usable hosts. Usable is always 2 less than total, so usable is going to be 30, right? Now, sketch out your subnetting tables. If your increment or range size or magic number or total equals 32, okay, then your first subnet is going to range from what? It's going to range from 171.24.16.0 to 171.24.16.31. Wait, is 17 between 0 and 31? Oh, look at that. Yes, it is. So guess what? Right out of the gate, we found the subnet where this IP is sitting. It is sitting in the first subnet. Wow, isn't that convenient? All right, so hit pause, answer all the rest of these questions. Now you should be able, now that you know the range of IPs in that subnet, all these questions you should just be able to fill it out in about 10 seconds. So go ahead and hit pause and start writing. All right, we're back. So what answers did you get? Did you get these answers? You should have. Network ID .0. The network ID is the first IP in the subnet, which is always .0. The broadcast IP is the last IP in the subnet, so it's .31, like we said. Already calculated usable. First IP, first usable is always one more than network ID, so it's .1. Last usable is always one less than broadcast IP, so it's .30. So this problem, once you figure out the subnet where this IP is sitting, this whole problem, and you kind of just sketch out the ranges of IP addresses for the subnets, right? This problem becomes really easy to answer. So let's move on. So here's another problem. Your organization wants to create a network with 18 subnets. What's the subnet mask? How many bits? What's the range size? And how many usable? Now, this problem, I will tell you, if you use the subnetting cheat sheet, this problem you can fill it in like 5 seconds. So pull out that subnetting cheat sheet and let's take a look at it. Let's go all the way back here to the subnetting cheat sheet. Now, we want 18 subnets. So let's look at this row, number of subnets. Let's see, 16. Will 16 give us 18 sub? No, it won't. So the next one up is 32. So we use this. So this is it right here. There are all your numbers right there to answer all those questions. So let's take these numbers and go back and answer the questions. We're getting there. We're here. So what's the subnet mask? Well, look at the cheat sheet, grab all the numbers from the cheat sheet and answer these questions. There you go. It's .248 if we're using 32 subnets, right? And then you just look up for your subnet mask, and it's 248, and it tells you borrow 5 bits, and it tells you your increment size is 8, right? Which is total hosts, and usable's 2 less than total, so it's 6. That one was super, super easy to answer with a subnetting cheat sheet. So let's move on. What's the network portion of the IP address 126.121.23.4. Now, if you get any of these questions in any of my classes, what is the network portion of the IP? Assume it's public. Assume we're talking about public. Like if you get this question right here, right? It's going to have a different IP. It may be phrased slightly differently, but if the question is asking what is the network portion of the IP address, blah, 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 assume it's public. Go back to your classful addressing chart, class A, B, C, look at your ranges, look at the default subnet mask, and answer the question. What's the network portion? What's the class of the IP? What's the default subnet mask? And that will tell you what the network portion of this IP is. So go ahead and look that chart up. Now, what'd you come up with? Well, this is class A, so the default subnet mask is 255.0.0.0, which means that only this first octet here is going to form the network portion of this IP address. Now, sidebar, okay, class A, how many total, okay, class A IP addresses can you have, right? Class A, like subnets. How many total class A subnets can you have, right? Well, they can only run from, what was the range? It was 0 to 128. So you can only have, if it's 0 to 128, you can only have a total of 129 total 129 total class A subnets for the entire internet. So you can probably see why class A addresses are extremely valuable. They're extremely valuable. If your organization owns a class A subnet, that is an extraordinarily valuable piece of digital real estate. I think Google owns one. I don't know how they got one because Google was kind of a late player to the internet game. Actually, I think there's some universities that have them. Anyway, they're extremely valuable. So let's keep going. Actually, let's not. We're at practice problem 2, and I think this video is running a bit long. So let's just cut it off right there, and we will work practice problems 2 later on.